Some equations have only one variable, and solving them is simple. We need to find the value of x, which fits the equation. In order to do that, we have to subtract. Minus 5 and minus 5 gives us x equals negative 3. Negative 3 plus 5 is 2. Sometimes we use multiplication or division to solve equations. Since 3 divides x, we detach it by multiplication. Times 3 times 3 gives us x equals 24. 24 divided by 3 equals 8. Or, since 7 is attached by multiplication, we divide. Divided by 7, divided by 7, and x equals negative 2. Sometimes you use more than one method to solve, in this example over here. First, we're going to add 5 to both sides, and that's going to give us x equals negative 14. Then, just the way we did before, we're going to divide by 7, and we end with x equals negative 2. But what if an equation has two or more variables in the same equation? Then they have to tell you which variable you want to solve for. Suppose you had ax plus b equals c, and you are asked to solve for b. We're going to do the same thing we did on the previous page. We're going to subtract ax from both sides. That removes ax from both sides and gives us that b is equal to c minus ax. When you're solving an equation with two or more variables, there are going to be variables in your answer, and that's to be expected. The reason why we were able to subtract the entire ax at one time is because they're attached by multiplication and stay together in addition and subtraction problems. Now suppose we were asked to solve for x. The first thing we would do is you say it. That gives us that ax is equal to c minus b. Now we have to detach the a from the x. They can no longer stay together like they did over here when the focus was on b. So since a is attached by multiplication, you say it. And that gives us that x is equal to c minus b divided by a. Rearranging or transforming equations with more than two variables or two or more variables have some trickier aspects, so now let's check them out. What do you do if your formula has a fraction? How do you solve for h when h is part of an expression with 1/3 in it? Well, the rule is remove the denominator, legally of course using algebra, by multiplying both sides of the equation by 3. We put parentheses around the whole thing to show that we multiply v by 3, and we also multiply the 1/3 bh by 3, and that gives us plain b times h. What I like to do if I'm solving for h is make sure that h appears on the left side of the equation. So I move the bh to here and the 3v to here and set myself up to be more comfortable. Math can be more comfortable if you know how to do it. So let's think about that when we're taking the math final, because we want speed and accuracy and comfort all to happen. Since b is attached by multiplication to h and we want to solve for h, then what we're going to do is divide off the b, and we end up with h equals 3v divided by b. If you hadn't cleared the 1/3 in advance, you would have had to divide by it, and that would have caused major complications in math. What if your formula has more than one cancellation in it? Suppose w is in between L and h, and we want to solve for w. Well, the first thing I did, as you noticed, is I moved my equation, or rearranged my equation, so that the w was on the left-hand side where I was more comfortable, and now I have to remove the L from the front and the w from the back. But since multiplication order is not an issue, all I have to do is divide by LH and divide by LH, and the L's cancel in the front, and the H cancels in the back, and we're left with W equals V divided by LH. Last, what if your formula has parentheses in it? What if you want to solve for W and W is inside parentheses? What do? There are a number of different methods we can use, but the one I thought you might like the best is to distribute the 2 and remove the parentheses, so that P equals 2L plus 2W. Then I did what I've been doing before, which isn't necessary, but if you like it, why not do it? And move the part of the equation that has the W to the left-hand side and put the P on the right-hand side. Then all we have to do is do what we did before for equations and subtract 2L. So we end up with 2W equals P minus 2L. And then divide off the 2. And I made one big line and wrote 1, 2 for my entire P minus 2L. However, on multiple choice tests, you might see this as the correct choice for what W equals. And this choice happened because you do divided by 2 here, and you do divided by 2 here, and you end up with P divided by 2 minus 2L divided by 2, and the 2's cancel out.